Welcome! In today's video, we're going to see how Excel can make solving engineering economic problems a breeze. We'll start with classic future and present value scenarios, then move on to more complex cash flow series. By the end, you'll know how to calculate exactly how your money grows, how much you need to invest today to hit a goal, and how to handle uneven cash flows, all using Excel. First, let's look at a classic future value problem. If we invest $13,000 today at a 9% annual interest rate, how much will it grow in 7 years? Since these are all single lump sum investments growing over time, we should use the following formula. F equals P times 1 plus I to the power of N, where F is the future value, P is the present value, I is the interest rate per period, and N is the number of periods. Excel makes solving this formula easy via the following FV function. Equals FV open parenthesis rate, comma, NPER, comma, PMT, comma, PV close parenthesis. Here, rate equals the interest rate per period, 9%. NPER equals the number of periods, 7 years. PMT equals recurring payments, which is 0 since this is a single deposit. And PV equals the present value of $13,000, written as a negative number because it's money we're giving up today. When done correctly, we should have a resulting future value of $23,764.51. It's that easy. Now let's flip the question with a different example. How much must be deposited today to have $10,000 in 6 years at 5% interest? This time, we are looking for the present value and will use the following associated formula. P equals F divided by 1 plus I to the power of N. Once again, Excel translates this formula into its own PV function, equals PV open parenthesis rate, comma, NPER, comma, PMT, comma, FV close parenthesis, where FV equals future value. Inserting these variables into this function results in a present value of negative $7,462.15. The negative sign here just reminds us this is money going out today in the form of a deposit. Finally, let's handle a real-world cash flow series where money goes in and out at different times. The cash flow profile for an investment is given below, and the interest rate is 6.5% compounded annually. What is the present worth and future worth of this cash flow series? Let's start with the present worth. Remember, present worth means what are all of these future inflows and outflows worth in today's dollars? Normally, we'd have to discount each cash flow one by one and then add them up as seen below. However, Excel can easily do all this math for us instead by using the NPV function. By providing the interest rate and the range of cash flows, it automatically applies the discount factor to each year's value, then sums them up. In other words, NPV is just a shortcut for add up all the present values. In Excel, we type the function as follows: equals NPV, open parenthesis, 6.5%, comma, E3 to E9, close parenthesis. Here, E3 to E9 is the range of our yearly cash flows. That gives us a present worth of $97.02. Now, for the future worth, we can take this present worth and push it forward 7 years using the FV function. In Excel, type equals FV open parenthesis 6.5%, comma 7, comma 0, comma negative NPV open parenthesis 6.5%, comma E3 colon E9 close parenthesis, close parenthesis. This tells Excel to use the present worth we just found and grow it at 6.5% for 7 years, resulting in $150.76. Or, since we already solved for the NPV, we can just type in equals FV open parenthesis 6.5%, comma 7, comma 0, comma negative B6. Excel's NPV and FV functions let you handle uneven cash flows quickly. And that's it. So here's the big takeaway. Use FV function in Excel to calculate lump sum growth, the PV function when you want to know today's deposit for a future goal, and the NPV function to handle uneven cash flows without breaking a sweat. Excel saves you time, reduces errors, and makes these calculations way less intimidating. If you found this helpful, hit like and subscribe. Thanks for watching, and I'll see you next time.